Algebra 2, Unit 3. This would be Section 1, so we'll call this 3-1. The start of a new unit in Algebra 2, and this unit is focused mostly on different types of equations that we're going to see. Today's video is on radical equations. So a radical that we see here, like the square root of 6x plus 1, radicals are not all square roots. They could be cubed root, fourth root, fifth root. We'll see mostly square roots here, but we will see some cubed roots and higher order radicals in this topic and throughout the year. But we're going to start off pretty basic in this video and just talk mostly about square roots. But when we see radical, don't assume it means square root. It could mean different power, and we'll get into that later. So we want to solve this equation. The square root of 6x plus 1 equals 5. And the thing for always solving equations is you're trying to do the opposite or inverse operation to get things away from the variable you're trying to solve. I'm trying to solve for x. Now, if this was just, 6x plus 1 equals 5, what would we do? We would subtract 1 because, x is being added by 1. And so the inverse operation of addition is subtraction, and that would give us something. And then we would, once it's just 6x, we would divide 6 on both sides because this is 6 times x, and the inverse operation is division. So you've known now for a long time that multiplication and division are inverse operations, addition, subtraction are inverse operations. Well, what is the inverse of square roots, inverse operation of square root? Like, that the square root of 25 equals 5. Well, how would I go back the other way? And that would be by squaring it. 5 squared equals 25. This really comes from a deeper understanding of exponents, and when we have our exponent chapter, you'll kind of understand why that this actually is a form of exponents. Radicals are a form of fraction exponents, actually, but we don't need to get into that now. But the inverse operation of square root is squaring, and the inverse operation of squaring is square rooting, and so on. So when I have a radical equation like this, I want to get rid of this square root here. What I can do is simply square both sides. Just like later on I'm going to subtract both sides, and later on I'm going to divide both sides. But I have to square both sides, and when you square a square root, what ends up happening, it's like the square root of 25 squared, for example, you just kind of get what was inside of it. Let me give you a simpler example. Maybe over here I'll do. Let's take the square root of 7 squared, and let's see what happens. But when you square something, you multiply it by itself. So that would be the square root of 7 times the square root of 7. And you know from Algebra 1 that when you multiply radicals, you multiply the numbers inside. That would be 7 times 7 is 49. But now we end up with a rational radical with the square root of a square number, and the square root of 49 is simply just 7. So what happened was when we squared the square root, we kind of just ended up with the number that was inside. It's kind of like the square root and the square, we could say cancel each other out in a sense. It gets a little bit more complicated if you had like a number in front of the radical, like 2 rad 3 squared. Because here you'd have to square the 2 and square the rad 3. This would end up being 2, the 2 in the front would square to 4, and the rad 3 squared would square to 3, and they would multiply to just be 12. And again, that's really something that you've learned in the past, but for now we're just interested that when we square root or square a square root, we're really just kind of left with the thing that was inside. So in this case here, the square root of 6x plus 1 squared is just going to give us 6x plus 1. The square root is gone. It was canceled out by the square. Now on the right side, that's 5 squared. There's nothing canceling out over there. 5 squared is 25. And now it's very basic, subtract 1 to get 24 and divide 6 to get 4. You do need to check these answers here a little bit, and if I were to plug in a 4 here, 6 times 4 is 24, plus 1 is 25, and the square root of 25 equals 5. That does check out. We are going to see cases where answers do reject occasionally, especially when we have 2 choices, called an extraneous solution. And the key to remember is that a square root cannot equal a negative number. Think about it again. The square root of 25 is 5 because 5 times 5 is 25. There's no negative times itself that gives us a negative here. So the square root of a positive can't equal a negative. And that's really confusing for a lot of students because negative 5 squared is 25. but the square root of 25 can't equal negative 5. It doesn't go both ways. And that's, a difficult thing for students to understand. When you get into inverse operations graphically, it makes more sense. But for now, just really remember this. A square root can't equal a negative. So when I check my answers here, I want to make sure that it works out. Number 2, the difference between number 1 and number 2 is everything in the left side is under the square root. But here, that's not the case. And just as like when we solved this, I had to minus 1 before I divide 6, there is a proper order of things. And we don't want to square both sides until the radical is isolated. So a lot of times the first step is to isolate the radical. And so that's what we want to do first. And what I mean by that is this is the radical, the 6x. The plus 10 is not part of it. So the first thing I want to do is minus 10 to both sides to make it the square root of 6x equals negative 6. Now that the radical is by itself, now we can square both sides. And when I square the square root, I just get the piece that was inside. And negative 6 squared is 36. Divide, x equals 6. Now I want to check my answer. So when I plug in a 6 here, I get 6 times 6 plus 10 equals 4. Well, the square root of 6 times 6 is 36. The square root of 36 is 6. And 6 plus 10 does not equal 4. So what we would do is we would cross this answer out and write the word reject. You actually do need to write the word. Now these are multiple choice, but let's say this wasn't multiple choice. Let's say it was a part 2 on a Regents. You do need to cross out the answer and write the word reject. And so the answer is not 2 or 3. It's certainly not 6. It's this answer right here. This is the symbol for no solution. All right, let's move over to the top right and do number 3 here. Square root of 2x plus 4, so that's your radical, then minus 3 equals x. So I need to move that 3 over before I square both sides. So I'm going to add 3 to both sides, and that's going to give me the square root of 2x plus 14 equals x plus 3. Now I can square both sides. On the right side, I will see 2x plus 14. I'm sorry, on the left side. On the right side, we get this binomial squared. And we've seen a binomial squared a bunch of times. There's a special pattern that occurs when this happens. You could write it twice and do distribution, but if you remember the pattern, we square the front part, and then the middle is the complicated piece. It comes from times each other doubled. So times each other is 3x. That would double to 6x. So times each other doubled, and then square the back piece, plus 9. Now, as soon as I see this x squared term and x to the first term, automatically your brain needs to start thinking about factoring. And the way we do that is we set it equal to 0. So I'm going to have to minus 2x, and I do that over here to the like term. So it's going to give me a plus 4x, and I'll have to subtract 14. Minus 14 gives us negative 5. Now I can factor this. Factors multiply to negative 5, add to 4 are x plus 5 and x minus 1. Solving them, we end up with x equals negative 5 and x equals positive 1. And especially when you have two answers, you want to see if they both work. Now looking here, neither of these are choices, so I'm guessing the answer is none of these. But we could plug them in to see if they do work. And I can see if I plug in a negative 5 here, that would be negative 10 plus 14 is 4. But I would end up with the square root of, I don't know why that marker got thick. If I plug this in, I end up with the square root of 4 equals negative 5 plus 3 is negative 2. And this is that case where a square root can't equal a negative, so this would reject. If I plug in a 1, I would get the square root of 2 times 1 is 2, plus 14 is 16, and 1 plus 3 is 4. So this would work. So the answer is x equals 1. These choices don't make a whole lot of sense here. Negative 5 would get rejected here. So this would be a case where a lot of times the multiple choice answers, it would be like negative 5, 1, negative 5, and 1. And so it wouldn't be both of them, and it wouldn't be negative 5. It would just be 1. Like I said, these choices don't make a whole lot of sense here. So it's none of those. But the answer is x equals 1. All right, there's another example here. very similar to that, but I think you get the point here. We're going to practice this a lot in class. So isolate the radical, square both sides, and when you square both sides, you just end up with the thing that was in the radical, but squaring the right side is going to require you to square a number or square a binomial. It may require some factoring, but whatever solutions you get, you got to check them. And if you end up with a square root equal to a negative or something that doesn't make sense, like 16 equals 4, then you got to reject that answer. And it's very common for that to happen. Sometimes both of them do work, so don't make that assumption that one rejects. Sometimes both of them do work, and sometimes a negative x works, but you need to check it to make sure. All right, so that's it for radical equations. We'll practice this more tomorrow in class. See ya. See ya.